Hey guys, welcome back to Codes. Today we're going to be solving Leetcode number 242, valid anagram. This is the third video in the series of solving questions from the NeetCode 150 list. And in this problem, we will be given two strings in this first example, S and T, and what we want to do is figure out if these strings are anagrams. So essentially what an anagram is over here a word or phrase formed by rearranging the letters of a different word or phrase, typically by using all the original letters exactly once. So to gain some intuition, in this case, anagram, what we'd like is to check if Nagaram is an anagram of anagram. So essentially by rearranging the letters in anagram, can we get Nagaram? And of course we can, because all letters have the same frequency in S as they do in T. So they appear the same amount of times in the strings S and T. Alright guys, so for the first solution, what we're going to consider is first sorting both of the strings S and T and then just comparing them. So we know that if we sort S and we sort T and they have all of the same characters, then necessarily once they're sorted, we know that they'll be equal to each other. And then we can just return whether S equals T after the sort. And that's essentially the whole solution to the problem. Now the time complexity of this algorithm is O of n log n, where n is the size of S or T, depending on which one is greater. And the space complexity is O of 1, since we don't use any extra space in this case. Alright guys, now in this solution number 2, we will be using a hash map, and in the end we will end up with time complexity O of n with space O of n as well. So the process for solving this problem is, well, let's walk through example number 1. So if we have a string S equal to ANAGRAM, so just the same thing as in example 1, T equal to NAGARAM, then what we would do is we would first initialize two dictionaries which keep track of the frequency S and then frequency T, right? So what this is going to keep track of is the amount of times we encounter each character in the string as we traverse it. So what we would do is we would set up a loop. We would do a quick for I in range length of S, and the algorithm would go something like this. So first we have a pointer that holds the 0th index and updates as we go along. This is just I. And on the first iteration, what we do is we add S at index 0th, frequency 1, so A1, and then over here we add the frequency of the first character in T, so N, frequency 1, and then we continue this process. So next add N and then add A, so here we add N with frequency 1, here we had A with frequency 1, and then continue by updating the frequency of A in the frequency S dictionary, and then add G to the frequency T dictionary, and so on until we've traversed the entire string. Now in the end, what this will give us is a dictionary that again keeps track of frequency of every character, and we know that if the frequency of characters matches up in both strings, then we do have an anagram by definition. That means that the only thing that differs about the two strings is the ordering of the characters. And so now we could head into the code solution. Alright guys, so to complete our analysis of the valid anagram problem, we will of course take a look at the code solution for the second solution that I provided using the hash map. Alright, so to begin the solution, the first thing that we want to do is first check if the length of S and T are actually equal, because if they're not, of course, they can't be anagrams of one another. So step 1, if length S is not equal length T, you can just early return. And then from here, what we can do is create our hash sets. So frequency S equals just an empty dictionary, and so does frequency T equal to empty dictionary. Alright, and then in the next step, what we'll do is we want to iterate through each of the elements in both S and T simultaneously, and to do that we will use an index-based for loop. So for I in range length T, what we'll do is we will add each character as we encounter it in either string to the frequency hash maps. So in this case, frequency S at index I will be equal to 0 in the case where we have not entered anything into the dictionary already. So if frequency S at index S, or rather if S at index I, so if the key does not yet exist in the dictionary, if S at index I not in frequency S, then what we'll do is we'll initialize frequency S at index S of I to be 0. We can do the same thing for frequency T. So if T at I not in frequency T, what we can do is we can say frequency T at index I is equal to 0, and then from here we can just say frequency S, frequency T are equal to frequency, or we could just instead just do frequency S plus equals 1, frequency T plus equals 1, specifically at the index S at index I and at index T at index I. Now, after we have accumulated what we need into the both dictionaries, essentially as soon as we've figured out the frequencies of each character in each of the strings, what we'd like to do is check that those frequencies are the same. So in the end, we can just return whether or not the frequency of S is the same as frequency T. Now, of course, this will return true if the characters in both S and T have the same frequency, and false otherwise. Now we can run the code, see if we've made any tiny errors. Doesn't seem like it, and then we can just submit the solution. And that is essentially the entire code solution for valid anagram. I'll see you guys in the next video, which will be coming very soon. And yeah, later.